Okay, so before we get too far into game development proper, let's spend a little bit reviewing programming, especially for those of you who are new to it or relatively new to programming, and also we'll talk about the details of Blueprint specifically. So before I get into that, I'd like to tell you one of my favorite programming stories, and that is what's known as the Parable of the Butcher. And this is a story, it takes place in a fantasy land of some sort. The butcher worked for many years using the same knife. He would just kind of true the blade and keep reusing the same knife over and over. Made beautiful cuts. Was one of the best butchers in the land, and became well known that his life was legend, or knife was legend, and that some people thought maybe there was like a mystical blessing that he put on his knife or something like that, right? And so at the end of his retirement, the king of the land asked him to come and present his knife as kind of a accomplishment, something they could put on a display for the greatest butcher in the land. And so the butcher comes and he goes and they go through a whole ceremony and there's all this and the butcher finally presents his knife and the king asks him, what is the secret? Did you get a blessing on your knife, or what kind of trick did you use to do this? And the butcher says, "There's no trick, there's no blessing. I just cut in the space between the meat." And the king looks at him and says, "What?" And the butcher says, "I cut in the space between the meat." So the idea is that because he never had to chop the meat, he never had to slice into the bones, he was slicing in the space between the meat. His knife never became dull in that way. So what does this have to do with programming? Well, the idea is that if you look at your problem, if you understand what it is you are dealing with, if you know the meat very well, then you can find the space between the problem. And rather than hacking it, rather than banging your head against it, rather than sawing through bone or sawing through tendon, you find the easy part of the meat and your knife just slides right through and the problems just sort of disappear. So you can find the most perfect piece of meat without ever dulling your blade. And I like to show the Salt Bae here, because if you've ever watched him actually carve a piece of meat, not just drop salt on his stuff, he does know very well how to cut the meat. Right? He's very quick and efficient. He puts his knife exactly where it needs to be, and he doesn't fight with the cut at all. So, given that, I strongly recommend that you get comfortable with documentation, because the better you understand the Unreal Game Engine, the better you understand what you're working with, the better you can deal with your problems and make them much easier than they would be otherwise. And so it's worth taking a step back and kind of examining what it is you're working with and try to find the space in between. Right? So maybe keep that in mind as you're looking at problems, especially as you start to get into the weeds in the middle of the night trying to fight a particularly nasty bug or some kind of weird mechanism. And that happens a lot with video games, because we are essentially creating a whole lot of interconnected mechanisms that are in some cases fighting with each other, and so you get all these kinds of weird and intricate bugs that can happen. And so when that happens, it's worth taking a step back and thinking about your problem and how you might approach it carefully. So it's always worth using your brain as the first line of defense against programming problems. Okay, so enough of that. Let's talk about actual details. So certainly to begin with, if you click on these question marks, you get to the documentation. Let's take a look at that. So if I click on, let's say, this actor here, of course we get a lot of pop-up documentation, and that can be useful to a certain extent, but if I click on the question mark, then it takes me over to Unreal's page, and when we have it, we see a good amount of detail on, say, what the actor is, right? So we've already kind of talked about the actor being the base character, or the base class that almost everything in the world is going to be a part of. They are in charge of sort of living in the space, and if they're a character, then maybe they're walking around, and if they're a pawn, maybe they're doing that. But you can find all of the basics about how an actor is worked with here, and so on, and we can go and see the character, and we can see the fact that the character is an actor. We can see some of the other parts, especially in this case, we see that the skeletal mesh is particular to characters specifically, and so on. Anyway, so it's worth getting comfortable with the documentation. It's worth looking at any documentation you can and spending some time with it. So the next thing to keep in mind, when you are programming, when you're fighting with problems, is getting debug statements. So, or debugging your code in general. So there are two fairly useful ways to debug. One is this print string function, and this one will go through any of your code and kind of tell you what's happening. So let's take a look at that. We'll come back to our first person character here, and we spent previous looking at this code a little bit. But let's take a look at how the input mechanism works, right? So to do that, I'm going to see. I think I will just grab the print string here. So I'm looking for the print string node, and recall that I'm in one case I'm right-clicking over here to do it, and then I'm using the search box here to find the print string in this case. So now I need to change where my execution is going. Remember that these white lines draw how our execution moves through. And so I'm going to draw a line from here to my print string, and then from here. And so now I know that whenever I move my axis forward, or whenever this code is executing, and actually it's going to execute constantly, because I'm always going to get like a 0 or a 1 or a -1. But now I can see what's happening too. So notice that these two are different colors, which means they're not going to work quite right. But thankfully, Unreal and Blueprints knows how to do an adaptation for me. And so in this case, it's grabbing a converter for me and just slicing that in, and so now I can say I've got this value being added in here. So let's take a look at that. We'll compile the code. We'll see our print string come through. And this is so-so. This is pretty much just going to print out the axis value directly. We might actually want to put a little bit more formatting to our string, so I'll show you that in a second here. If you've ever played Unreal games with where somebody's forgotten to take out their debugging lines, and then you'll see these kinds of extra blue numbers showing up on the side, the ones that we're seeing over here. But this shows us what we're looking for in this case, which is that we expect the input to be between 1 and -1 when I'm pressing forward or when I'm pressing backward. And we kind of talked through that, but now we can look at it explicitly and see that we see those numbers exactly. So then the other way we can do it is to actually have a build string here, where we say we're going to bring in a floating point value. And now this one's a more complicated version of this, right? So we're going to bring in our floating point value up here. We are going to this, and we're going to say our prefix value is my input. And again, we'll come back and look at the input a little more carefully and understand the positive and negative things here. But this is mostly just to talk about these debugging messages. So I'm going to actually bring these up and out of the way so we can kind of see that they're happening over here. So in this case, I wanted to append a little string because it's hard to know what I'm looking at. Maybe if I'm using multiple debug strings, I might see many, and then I maybe want to know what they're dealing with, or what I'm dealing with. But now I can see that I've got like an extra little bit of information, right? So now it says my input, so I can differentiate maybe this from. I might say this is my forward value, and then I could also say put my move right in there as well. So I'd see both of those strings getting output. All right. And the other way that we can do this is, let's go ahead and, I think there's a jump around here. There we go. I'm going to put a breakpoint here. So again, what I'm doing is toggling, and I'm saying toggle this breakpoint. I can either remove or disable. If I toggle it, it just turns back off. A breakpoint will cause my game to pause whenever I hit it. Okay. So in this case, I've got all the normal text, but as soon as I hit the jump key, Now it pauses, and what's kind of useful here is not only that it pauses the game, but I can come back over and look at my blueprints, and we see another useful feature of the blueprint, which is that we can actually see all of the execution flow, right? So all of these events are actually firing every turn, including the move event, or the move forward, the move right, turn rate, all these things. And we're seeing the flow of execution as they go. So all of them are really only doing one step, right? We see this is what is normally our white lines that connect things and we're moving through. But we can see the flow of execution and see where each of these values is coming from. We can also hover over individual lines and see what those lines look like, right? So we can say, right now I have a pretty high frame rate, so my delta world seconds is small. I can look and see that, well, in this case, this one's kind of useful because I've got both a pressed and a released, and in this case I did the pressed version, so it is jumping and is not doing the stop jumping command. But this is another way to look at values as well. So not only are you paused seeing the flow of execution, but you don't necessarily have to output the values to see them. You can come over here and hover over the lines and see debug values, right? So of course, there's not a lot that's interesting happening right now. When you have AI, and when you start getting into AI, and I'll remind you of this when we get there, this is another useful way to look at things that are happening that you're not necessarily controlling by input. Okay, so the last little piece of Blueprint's usefulness are these comment blocks. So these are actually very nice to use because they help sort of make sense of your code. Yeah, and of course you can zoom out and see them. You can also move these entire blocks around, right? So if I grab the block from like its header, I guess not all the block was in there. If I grab the block from its header, and I've actually got all my nodes inside there, then all the nodes come with me, right? And so that can be very useful to organizing your code and keeping it together. Also, you get segments. So this is my movement segment, and this is my I guess stick input, which also has to do with like the mouse input axis. Actually, I guess the mouse input is here. Anyway, so this is useful, right? You can look at it in English. You can understand what your code's supposed to be doing in sort of the English version of it without having to worry about all the pieces. So it's worth knowing how to do it. So let's I'll leave that as the mess that it is. But let's go highlight these guys. And so what you do is you highlight a group. You pick a group. We're going to create a sub comment here. If you just have a group of nodes as you're creating nodes, then you can create the comment that way. And then we create a comment from selection. So doing so, then it creates this block for us, and of course we can go and modify. We modify the text here by click, pause, click, or we can come over here and say this is a new block. Right. And if you didn't quite hear me say that, there's a common way of dealing with edits in Windows especially, but with the editors and all that, called click, pause, click, where if you've got something that's editable and it doesn't just immediately become editable, right? So a lot of these things you click once and they become editable. But something like this, you actually have to click it, pause, and then click it again, or maybe double click it, right? So those are a couple different things to keep in mind. You want to click, pause, click, double click, or just click once if it's an actual editor. But if you get lost, try one of those methods and see which one's going to actually let you modify it, if you know it's supposed to be modifiable. Okay, so that is a lot of the structure of blueprints. And again, I advise you as you are building these things to keep all of this in mind. Keep your documentation in mind. Remember that you have the option to do debug strings and breakpoints to be able to look at and analyze your code, especially to think about your code. And of course, to use comments to remind you what you're doing, especially as things start to get complicated. When you're creating it, break things up, make them small items that you can think about in sort of reasonable chunks. Okay, so let's review a little bit about programming, our programming structures, especially those that we're going to use. So we have variables. They're also member variables, as they're sometimes referred to, or just members. These are locations in memory, right? These keep track of a value. You have floats, you have bools, and so on. But this is your data, right? And then you have functions, methods, and procedures, all of which are kind of the same names, also subroutines in some cases, and these are a series of instructions, right? And so you have your data, and you have your instructions that use that data or use data like that. And what we're seeing is that in blueprints, we often don't actually have explicit functions or methods that often. Instead, what we have is an entry point, like the starting point for the white line, and then we trace our white line through a series of nodes, and then we have the last node in the series. That's kind of our end point, right? So we have a starting point and end point. And that is true of functions and methods and so on. They all have starting points and end points. But in this case, we are really just doing them by virtue of tying into, say, these event begin play. We'll have a starting point here, and we'll trace it, and then we have an end point over here. Really, what we've created is a function in this case, so a particular string of execution, a string of instructions that we want to run. But it's not quite as explicit as we see in other languages. You can create functions in blueprints, and what ends up happening is when you create a function, you take an input, and then you also provide an output, and what you're really doing is creating one of these blocks, right? So each of these blocks, in some sense, is almost a function on its own. Say set hidden in game is a function, has a little bit of input, a little bit of output, but there's a lot of interesting things happening inside that we kind of ignore as an almost literal black box, right? So we've got a black box here with a blue header, and a lot of the details are hidden inside. And this is useful because we really don't want to care about those details all the time. We kind of just want to make our games, right? So that's one of the use cases for functions, is to hide the details. But you can also just think of the fact that a string of execution following a white line is a function in blueprints. Okay, so variables, I think, always start with a letter. You have a few more options in blueprints, but it's usually a good idea to give them reasonable names. They're all a single name when you do it. But you have a lot of the same types that you get with all programming languages. You have the Boolean, the int, the float, the string. Probably those three, the Boolean, int, and float, are going to be the ones you use the most. String you might use occasionally. There are enumerations. Those are probably used less often. You'll use them, at least in terms of the Unreal Engine, as drop-down values, but you probably won't create any of your own that often. Of course, there's vectors and rotators, and then the important ones, we can keep references to transforms and objects. Those are often when we want to communicate with some other object, right? So if we're shooting somebody, essentially what we're saying is, I want you to take damage, right? I shot you, now you need to take some damage. And so we will use a reference to the other object in that case. Rather than damaging ourselves, we'll get a reference to the other object and call a damage event on that object, for instance. And we'll see a little bit of that later as we start to build out the FPS project itself. Okay, so let's review now in Unreal where we create the variables. So I'm going to look at my cube blueprint. So recall again, we created this blueprint out of the cube rather than jumping straight into the first person and looking at the various things that we're seeing there. Let's spend time with the cube blueprint, which is the default one. So this is, again, this kind of default blueprint that you get to see when you do almost anything. It'll give you a begin play, a begin actor overlap, and an event tick. So here on the left hand side is where we can control our functions, our macros, and our variables. We'll look primarily just at the functions and variables, as that's what we're talking about. So when I click new there, it gives me the option to create a new variable. So I can say my Boolean, and now it's a Boolean value over here. I can change the type if I want to. So if I've not yet decided what type I want, I can choose byte, integer, and integer 64 are all essentially the same thing. Integer by itself is a 32-bit int, there's a 64-bit int, and a byte is an 8-bit integer. If that is not very familiar to you, the details actually don't matter. It only really matters for efficiency, and most of the games that we're going to make are not going to be putting any strain on the computers, assuming that you can already run the Unreal Engine itself. Unfortunately, that's kind of a big deal in the first place. So most of the time you can just create an integer and not worry about it. Those are going to count from 1, 2, 3, and so on by whole numbers. And then floating point values are the ones you use to get rational values, and often that's going to be the one that you're going to use, unless of course you're doing something careful with, let's say, health, and you want your health to be from 1 to 10 in integer values. But a lot of the times floating point values make for useful values, even in the case of health sometimes, because you can have a health from 0 to 1 and act as a percentage essentially. So 1 is 100% and 0.5 is 50%, say. And then of course we have the string and so on. So let's leave that as Boolean. I can create another one, my integer, and we'll call this my health. Let's say, yeah, so my health is going to be an integer value, and then we'll say my speed is, we'll call it max speed, even though we're not going to actually put anything together right now. And the max speed we'll have as a float, right, because that's probably going to scale the speed that we move in a direction. Okay, so all of these things, we've created a set of variables that we can then use in our blueprint scripts. Of course, they don't actually exist yet because we need to compile, so you'll want to remember this. You want to both save your blueprint, because you'll see the little star up here that says we made changes, and then you'll want to remember to compile it, and once you've compiled it, now it's code that exists, and so you can actually access things like the default value, right? So my Boolean, my health, maybe I'm going to set the default value to 10 there, and my max speed, I'm going to set the default value to 50. Remember again that blueprints, Unreal is in centimeters, and so by default, unless you somehow rescale everything, you're going to wind up in centimeters, and so this is 50 centimeters probably per second, unless we're being weird about our time. And again, I'm going to compile it, and you'll notice it says a default value. There's actually no other way to change it except that I can, at least from this view. So this is essentially going to be the initial value unless I change it in code. That'll be the value that stays. If we want to use these values, we can grab them from the side over here, and we can either have a get max speed sort of function or a set max speed. So if I get max speed, I get one of these little nodes on the right that lets me say, well, we'll just do print string here. Now in this case, it's actually going to give me a duration. That's interesting. Well, I want to plug it into the string here. I'm going to get rid of the key there. Actually, that is another useful thing to talk about since we're right here on blueprints. The way I'm getting rid of these green lines, or this extra green line right here, is I'm holding the Alt key down and clicking on that green line. And so by doing that, it deletes the line that says true from all the lines. So if you wind up getting an extra line that you didn't mean to, the easiest way to get rid of it is just to Alt click on it. That's the Alt key. But you can also redirect that line, so especially if it's a white line like this, you can really only have one white line moving through time, through your execution path. And so if you redirect it, it will go to the new place. You don't necessarily have to delete it to redraw the line. Okay, so we can get our max speed. I can also set max speed, and then this one is going to give me an indicator on the left that says, you know, at this time, I want to set my max speed to my current max speed and just move through. And we'll see another example here in a minute. I might do like some mathematics or whatever, but we'll take a look at the math in a second here. Yeah, so we can get and set our variables, and we do that again by dragging them from the left over here into the view, and then we can start using those variables as we've already seen with you know, things like grabbing, say, the base turn rate or the base lookup rate. We're just grabbing those from over here and using the settings. Now, the other thing that we see over here is this little eyeball icon, and that tells us whether or not we can modify that as a level designer. And in some sense, you're exposing it to your level creator, level designer, or to yourself as part of the level. What that says is, I've got a blueprint which has a pattern to it, but this particular instance of the cube, I want his health to be 20, right? So most of the cubes that I create a blueprint from, they're going to have health 10 because that's the default value, and that's where this default comes in, right, where it makes sense as a default. But I want my initial or default value for this cube to start out as 20 for its health. and maybe I also want it to be faster, right? So now I'm going to make it 10 times faster than all the other cubes. So by setting the eyeball active over here, then it gives you the option to set them inside the scene view, and you'll notice I'm over in the scene view looking at this cube. And so if I get rid of, say, my boolean here, because that actually shouldn't have been a public variable, I don't ever want my level editor person to change that. I only want them to be able to set the health and speed on certain cubes in the world, right? So I can get rid of that and make it non-visible. Okay, before I move off of variables entirely, there's a whole set that I forgot to mention. Let's look at the, let's create a vector, or nearly forgot to mention, a vector. So we've seen some of these. A vector is a value that has the x, y, and z associated with it, right? So it's always a 3-vector. You can also treat it as a 2-vector by just ignoring the z value or ignoring the y value. What we get a lot of the same results here. Vectors often are, in this case, we're using it as an offset, right? Where is the gun sitting relative to our character? I'm not sure exactly where that reference is. It's over here. So it's in this case, the gun offset is used to spawn where the character is, or where the bullet gets spawned relative to the character. We can also create rotators. Those let us control the rotation around a certain amount. The other one that you'll probably use a lot, the other kind of variable, is this complex variable, the transform. And this one, or the actor actually. Let's see, my actor reference. And this is a reference to another actor, right? So we have sort of an automatic reference that we can use. That's self. Oops. Self. Get a reference to self, and you see that it's the same type. And so often, you'll see that there are certain things like we want to rotate a particular pawn or a particular actor, and in this case, it's going to be ourself as default. We could actually get a reference to ourself and pass that in. Technically, if we wanted to, we could rotate another character. So if you cast a spell on them and it causes them to spin, then you might have a reference to that actor and then cause them to rotate around their axis or something like that. It's not often. Usually we're modifying ourselves by virtue of input or something like that. But again, if you've got an actor, that's how you start getting references into them to say, I want to apply damage to you, or that kind of thing. So those are the other more complicated variable types that we'll deal with. Okay, so as you're all probably aware, computers were originally created to help us do math. They were used to help us do missile launches or artillery launches, break codes, break German codes in the war, all that kind of fun stuff. It helped us launch satellites and spacecraft as well. But of course we have people able to do math by plugging in all these numbers, but computers are very good at it. And so of course we have all of that available to us to do add, subtract, multiply. We can also do sines and cosines. And maybe importantly, and most importantly, we can do Boolean logic and condition, where we turn, conditions are essentially taking a look at a Boolean and deciding if it's true or false. And if it's true, we do a thing, and if it's false, we do a different thing, right? And so we'll take a look at that in a second. But if you're not already familiar with Booleans, then it's worth becoming very familiar with Booleans, because logic, and especially Boolean logic in games and computers, is kind of crucial, right? That's kind of where all the bread and butter of what we're doing. It's like, if you have this and this, then the door unlocks, or if you've got this option or this option, then you win the game. And you give them multiple choices or something like that. So all of those kinds of things, the ands and the ors, all boil down to game mechanics at the bottom level. All of our game mechanics end up being Booleans to some degree, right? We're looking for certain conditions to be true or false, decide if you win or you lose. So it's very important to understand these. So so these are what are known as truth tables. So again, if you've not seen these, then make sure you're very comfortable with what's going on here. If I have two values, a and b, which are both Boolean values, and they're both set to false, then if I AND them together, they're false, right? If I OR them together, they're false. If I have A is false but B is true, the AND value is false, right? So what I'm looking for is essentially that A and B are both true in order for the AND value to be true. Here I'm looking for A or B to be true in order for the OR value to be true. Now if you think about this, you can also think about this as a little function that takes A and B as input and outputs its own true or false value. And the importance of that is you can then combine ANDs and ORs together, right? So you can say A or B and C or D, and you get interesting logic that way. Or you can say and this or that and this or that. And that's where we start to come into the kinds of interesting and complex logic that create the game mechanics that we like to play with. So I mentioned briefly conditions, may not have been entirely clear on those. Those are the case where we take a regular variable like a floating point or an integer or a more ordinary variable, and we compare it with, say, greater than or less than. So in this case we're comparing that the my_var is greater than 0, and it becomes a Boolean, right? So this value is true or false depending on whether my_var is greater than 0. If it's negative, then of course it's not going to be. And also checking whether it's less than or equal to 5. And so by doing the AND here, we're looking to see whether my_var is between 5 or not. We might do something like this with, say, speed to say, you know, if you're going faster than a certain speed, if you fell off a cliff, say, then your character dies and you have to start over. Or maybe if your health is less than 50%, then your character is weakened and you know, can't fight as strongly or something like that. So these kinds of comparisons become the way that we perform the game logic. And we'll look at branching here in a minute. This is really just looking at the conditional operators. So let's take a quick view back in Unreal to see the way we might play with these. So again, we saw how we can get a value like max speed, and we might do something like multiply it by our delta seconds in order to get a distance, right? So if we multiply speed by time, we get a distance, and we might do something like add this to, or multiply this by a direction. So if I had, say, a direction vector here, probably something like where I'm facing, right? Then I can get that value, and I can multiply that together too. So I can multiply a vector times a float, and I scale that vector up, and then of course this could be applied to my position, and we'll see things like that here shortly as we go through like the first project, the first chapter of the book. And then, as I was mentioning, we can also do things like comparison. So we can say, is my integer greater than 0, and then out of that I get a Boolean operation. And so I can use the Booleans to say, you know, is my health greater than 0, and is my health, let's do that same thing, less than or equal to 5. Right, and so again I'm typing things like less than or equal to find these nodes. And so now I have a Boolean operation here that I can then use to do a branching condition, and again we'll talk about branches here in just a moment. So coming back to functions, they're a little bit different in Blueprints. As I mentioned, pretty much every block that kicks off a sequence of events can be treated as a function. In fact, you can call it from other locations. You can sometimes kick off that event as a function in other locations. You can almost treat the comment block itself as a function by storing everything together. There are functions within Unreal itself, and you can use these as a way of reusing blocks or reusing a group of operations in its own block. Okay, so let's take a look at how functions actually work inside Blueprint. So we always start with this construction function. There's not a whole lot going on in here. It is essentially the constructor. If you're familiar with C++ or you've done some object-oriented programming in general, constructors are very common, and so we get a construction script that does that kind of thing. Let's take a very simple, trivial example that's probably not terribly interesting, but useful in this case. So we're going to say damage health, right? And again, this is not exciting because it's very easy to damage our health by just subtracting from it in the normal script. But let's just take a look at how it works. So so I want to create a new function. This is going to create a new block available in my standard event graph, where I can connect it, say, up to a tick event or something to damage my health. And I will take a new parameter, which is the damage amount, And since we were using damage as integer, I'll keep that the same here. And so this is going to create an input pin for the amount of damage that I can take, right? And so then, given that, I'm also going to take the input damage, or the current health, and then I'm going to output the new health, right? So we'll go take our current health in and output the new health. I can actually grab current health as well, so in fact I'll show you that example instead, just to so we can use that. So because we're inside a function that's attached to a blueprint, this is where these variables become known more like a member variable. So they're a member of the cube blueprint and not necessarily a local variable. So a local variable would be something like temporary value. Maybe I'll create yet another integer here to store my temporary value before I turn it out. This one I can use inside, so I could set temporary value, and what I'll do is this, right? So I'll start doing the operation here. I'll say I'm going to actually subtract. I need to make sure I get the order right. So I'm going to subtract the top from the bottom, or the bottom from the top. So my health is on top. Damage is getting subtracted from it, and then the output's going to go here, right? And so I'm going to store this in temporary value, and then it's going to become my output as well. We'll see that in just a moment. What I want to show you is that if I come back to the event graph, my local variables have gone away. So I can always see these member variables, which are part of the class, in any part of my function group, or any other piece of the puzzle here. But the local variables are local to the function, and so this is a great way to encapsulate complexity. If say damage health was actually a very complicated function with a whole lot of cubes or a whole lot of nodes out here, it'd make a lot of sense to actually hide it inside a function so that you don't have to worry about the complexity when you're looking at the event graph. After a while, even if, as we looked at the first-person shooter, you get the first-person example, you get quite a lot of nodes, and it's just hard to look at. Even if you group them into component blocks and everything, it becomes very complicated to look at. So when you get to that point, maybe 10 or 15, I'm not sure what the right strategy is there. But whenever it feels too complex, is a good time to start thinking about doing a function. The other one, of course, is if you find that you're repeating the same pattern of a certain set of blocks. If you've done it twice, it's probably a good idea to start thinking about making a function, because if you do it a third time, you're almost definitely going to do it a fourth time. It's kind of the rule of 3. Okay, so we have our function here, damage health, and we're also going to create an output which is going to set our health out, right? Now technically I could set health in here as a side effect. It's a process that's known as a side effect is when you modify a member variable rather than having a function that does nothing except to modify its own local values or its return value. So in this case we'll have a non-side affecting damage health, which means that I'm going to return the value. This is the new health value, right? So, and again, I didn't really need to keep this temporary value. I'm using this as a showpiece. Again, a very simple example, not terribly interesting, but don't want to get too complicated too early. Okay, so given that I've got this function, now I can bring my damage health in as a function, and you'll notice it looks a lot like many other blocks that we were seeing. So if we come back to our first person example and bring up that, we see these blue blocks here, and these are really, in a lot of cases, these are C++ symbols or something like that, but essentially it's a C++ function that we're calling. And so here, and I was double clicking these to attempt to open them, and so it may actually decide to open Visual Studio on me. We're not really going to get into C++ in this class. We're going to kind of strictly stay within blueprints. However, you're welcome to dive in on your own. But because this is a blueprint function, I can double click it and then go look at the contents of it. And so what you're seeing is this is a great way to kind of hide that level of complexity, right? So every tick, let's say I wanted to, I was damaged or I had some kind of poison effect happening, right? So every tick I need to take a certain amount of damage. So I'm going to say, I'm just going to set the damage amount to 1. I could have that be like your current poison value. And then the new health becomes set my health, right? And so now I'm calling this function. It's actually operating on all of the nodes that are inside here when I double click it. And we can do that. Again, this example is not terribly complicated. We could very easily just do the same math to subtract from my health, and I recommend you do. to start with, as a way of kind of understanding what's happening. But as you start to create more complicated structures, think about turning those complicated structures into black boxes that you can hide the complexity behind. And so hiding complexity is always a great way to, coming back to the butcher metaphor, a great way to kind of be able to think about and reason about your code without having to worry about the complexity, without having to bang your head against the code. Well, I guess one other example, you can select a whole group of nodes. So if you do find you have that kind of complexity, you can copy them, and you can come and create a function and then paste those nodes using, like, in this case I did Control V. I'd have to go back up here to do the actual cut and copy kind of thing. So I'm going to Control X to get rid of those because I don't actually want those nodes. Alright, so the last thing I want to show you is a branch here. And we did see this already with the button pressed and released, so that's kind of a simple branch with inputs that uses that case. We'll be getting into inputs in the next set here, but let's take a look at a branch. So I can just say I want a branch here, and this says, okay, so if my health is, oops, need to grab the white line over here. Let's delete some of this complexity. Rowing. So if my health were between these two values, so I knew my health is between 0 and 5, I actually did that correctly before, then this is the true branch, right? And so I could say print string health is in the good range, right? And then the alternative is I can say health is in the bad range, right? So I could, this of course is not very interesting. We'll do real operations down here. And so these kinds of branches then let you do the operations that would say. So again, we already talked about, let's say I had a tick that said I was poisoned, right? And so I might do something like, let's walk through that actual example. So I'm going to have poisoned seconds, and someone's going to set that on me, right? We won't worry about how that happens, but I'll say poison for 10 seconds. Okay. So then, given that, every tick, I'm going to subtract the delta time from my poison. Oops, I made poison seconds be an integer. I actually want that to be a float. At a time, you should almost always make a float. So I'm going to get my poison seconds, and what I'm going to say is I'm going to subtract the delta time from that. And so what that's going to do is say every tick, it's going to figure out the delta time. How many, it depends on how many frames per second or how quickly the ticks are happening, but that's going to be exactly right for however quickly the ticks are happening. I'm going to subtract from my poison seconds and set this back into poison seconds. So now I know that I've got a new updated value for that. And then I say, is this greater than 0? So if I'm currently still poisoned, and that's what this would mean, right? If I'm still poisoned, then if it's true, I need to damage my health. Right? I'm going to damage my health by 1, or maybe the poison amount. I might even save that as a thing. So here's a really, here's a full example of that. I'll go ahead and delete some of this complexity again. So here's one that says, if I'm poisoned, let's say it starts with 10 seconds as default, right? So I sort of start the game with 10 seconds of poison. That's a terrible way to start a game, but you never know. It might be a very dramatic starting point. So for 10 seconds, we're going to, every tick, subtract from our poison. If our poison continues to be above 0, we will damage our health. And if our poison is not 0, then it goes down to this false branch. And this one might be, maybe we start regaining health back, or we slowly recover. So maybe we can damage our health with -1. In fact, technically that's possible in this case. I'll show you what that would look like. Let's say damage health, and we'll do -1, and since we know that we are subtracting our damage amount, it actually ends up adding to our health that way. Oh, you know what? Can't do both of those. All right. You can do multiple lines coming into one, but of course we need that set health to work this way, so let's do this. And this white line comes here. Okay, so again, walking through this branch, we're poisoned for 10 seconds. We're subtracting our delta time every second, updating our poison seconds. If we're still above 0, then we come over here and damage our health, and if we're not, then we start regaining our health back. Right? So we negatively damage our health, which is healing in this case. Since I do have one more complicated example in my notes, I'll go ahead and show you that as well. I won't walk through this in the blueprints, but you can see here we'd have my health or my hit points. If we're less than or equal to 0 in this case, this is a little different than we were looking at before. We were looking at greater than 0. If I'm less than or equal to 0, then I'm going to die. Alright, so I'm dead because I no longer have any health left. Right, my health is negative. In the false case, I then add a new branch and look at a second condition. This second condition is, am I less than 5? So this is like 50%. So if I'm less than 5, then I'm going to set my move speed to slower. So now I'm a little bit in trouble, right? So having difficulty because my health is low, so I'm moving slower. Otherwise, if my health is greater than 5, then I'm doing okay, and my move speed is full. So here's a fairly simple example to add a little bit of complexity to your gameplay, just based on sort of complicated branching mechanics. So then moving on. So we've seen our variables of both public and private, our public and private functions. We also inherit variables and we inherit functions as well. And so you can see, for instance, the inherited functions that we get by virtue of being an actor here. So we can override the default behavior for some of these functions. Let's see, the variables, or generally we're looking at those elsewhere. So we see those kind of coming in through these parts over here, or we can see them as various variables that we can get through all of these. So we can find, there's quite a few. Unfortunately, it's hard to look through all of them. If I look at, say, the actor, I can get my owner or my parent actor if I'm contained within a parent situation, or I'm a component. The point here is that we so object-oriented programming, we do inheritance, and through inheritance we get more features. We will actually go more into detail on this, especially when we talk about the architecture of the game engines in a different lecture. But it's worth noting that these are all available because, in this case we're an actor, so we get everything that's an actor. Cube Blueprint in this case is really an inherited class of its own. Okay, so we've kind of created our own class. For those of you very familiar with object-oriented programming, and we've inherited from the actor class, and so we've created our new instance here, including with the component and all that, or the default static mesh component. So we inherit all of that capability as well, and so other entities in the game can all treat us as an actor, and they understand how to deal with actors, and so they treat us the same way because we are an actor, right? But in cases where we want to actually, use our class specifically, then we also have these extra pieces like the poison seconds that we did here, or my health, that we added onto that. Okay, so the last thing we'll talk about here is references to actors, and I'm actually not going to go into detail. I'm just going to talk about it. We'll kind of see this come through in practice as we start looking at these things. I'll show you one brief example of where we have a reference to another actor. It's pretty straightforward. But this, of course, is the other piece of games, right? So we have the logic. We understand that maybe our health is going to be slower, or our speed is going to be slower if our health is lower, or we're going to take damage if we're poisoned. But how do you actually poison someone? And that's where you end up with the other part of games, which is I've either got AIs or other opponents or other characters or blocks that I need to move or levers that I need to pull, and so I need to modify other actors in the world. Those actors could be doors or characters or levers, and so we need a way to talk to those. And so primarily we have a variable that represents that we can either store or we get a hold of. And then we can call values, so we can call the direct functions on there. We can modify the variables if the variables are publicly visible. And we'll see examples of several of these, maybe all of them, I believe, over the course of the semester, and get to those. And then, the question is, how do we get references to another actor? There's a number of ways. Again, we'll see those. Probably the two that we'll see very early on are collision or overlap. And so, when you're colliding with that actor, you can then easily get a hold of it, and we'll see an example here in a second. And then, I say the rest remain left as an exercise. We'll actually see most of that when we start talking about AI. So AI and sensors are the other ways that you actually get a hold of other actors, primarily through game mechanical means. There are even more ways. You can just ask for all of the actors that exist and things like that, but those aren't necessarily all that interesting unless you're doing something a little weird. Often the sensors are kind of the limit of it. So we've seen this event sitting here the whole time. And this is the case where our actor has started overlapping with another, right? So we are colliding with it, or we're just walking onto it, or it's a lever, or sorry, it's a pressure plate or something like that, or even a door that we started pushing into. So we'll get an overlap event in most of those cases, and we have this other actor reference here. So I can, if I wanted to, store that, and so I could say, let me keep this object type as actor. Oops, pressing the wrong buttons. And because it's an actor, collider object, right? So I could say collider object. I'm going to set my collider object to that. Probably not that interesting in most cases. We probably don't need to save who we interact with, unless maybe we want to keep some detail about them. For the most part, you're probably going to do something by grabbing some properties off of this actor. So if we do that, we already saw some of these kinds of functions. We might have like rotating the actor, or so we could say add yaw or something, or add movement. So that could be an initial one. Every time we hit someone, we might want to add some movement to them. So we say we'll call it add floating pawn movement, right? So of course there's other things we might want to do, but actually that's gonna add a property to it, but that's okay. For the purpose of the example, that's what we're doing here, and we'll see real examples here in a little bit. But yeah, so that's kind of the final set where we have another actor, and we really want to be able to call the functions and scripts on that actor, or that component or whatever that we're looking at. And so we'll dig into that more, especially as we dig into Chapter 1, but that kind of covers the review of programming for now.